Hey everyone, Mr. Eller here, talking about Module 3, Lesson 4. Today we're going to talk about unstable nuclei and radioactive decay. So we're still in that atomic structure module, but we're going to talk about the unstable atoms today. So let's move forward here. If I can get my computer to work. There we go. Our focus question is, how can atoms change? So think about that. How can atoms change? Hopefully we will be able to answer that towards the end of the video. As always, here's our vocab. Go ahead and check those out in your guided notes. We got definitions in there for you. Refer to those as needed throughout the lesson. And let's get it cracking. So the rays and particles emitted by radioactive material are called radiation. Anytime that you hear somebody say radiation, that's what they're referring to. They're actually referring to the rays of energy or particles that are actually given off by the atom. Okay, that's right. The atoms will give off particles. Okay, and it's called radioactive decay, which we'll talk about. Okay, and a nuclear reaction is different from a chemical reaction. A chemical reaction is simply the rearrangement of atoms within molecules. Okay, so just a different. You take a certain arrangement of atoms. If you rearrange those atoms with different partners, things like that, that's a chemical reaction. A nuclear reaction is actually where we go into the atom and we mess with the nucleus. We change the nucleus somehow. Okay? And that's a totally different type of reaction than a chemical reaction. All right, let's take a look at a few processes here. This might look familiar to you. Okay, we have liquid water in a beaker. And remember, liquids fill the bottom of the container, right? So we got liquids floating around in here. We got gaseous water that is more spread out, randomly moving around. This is in an open system, so that gas is allowed to leave and go into the surroundings. Okay, and that type of process is actually called. Trying to move forward here. There we go. Physical change. Okay, that is a physical change. If we look at this equation here, okay, we have liquid water. Okay, so here's our water molecules, and they're going to turn into, and this is actually a typo, this should be 2 hydrogen gas molecules. Okay, so each one of these white ones are a hydrogen atom. Okay, and then you have the oxygen, and red doesn't show up on red. So you have the oxygen atoms over here, and you get one of those. Okay, this process here is called a chemical reaction. Okay, so that is a chemical reaction because we have a rearrangement of these atoms. We started with 1 oxygen with 2 hydrogens, and if we rearrange them and just put the hydrogens together and the oxygens together, we've completely rearranged all the atoms. That is a chemical reaction. Okay, so the next one, if we look at this, we have uranium-235. So it has a mass number of 235. It has 92 protons down here. Okay, so 92 protons. Right? Remember, this mass number is protons plus neutrons. Right? So we have this massive atom here, and that is unstable. If it gets hit by a neutron, okay, a single neutron comes in here and smacks this uranium atom, it's going to split that atom into barium and krypton. Okay, I believe that's krypton. See, I don't have my periodic table memorized. Yeah, that's right, krypton. Okay, and so you get 2 daughter atoms from that, and you also in return get 3 neutrons, which will actually go out and find their own uranium atoms to attack and bombard and split those atoms, and then we get what's called a chain reaction because it just keeps feeding itself and multiplies and multiplies and multiplies and just gets way out of hand very quickly, and that's why nuclear reactions are so dangerous and powerful, like the nuclear bomb. Okay, so as I've been talking about, this is an example of a nuclear reaction, because we're actually going into, this is drawing right here is not the atom, this is just the nucleus. Okay, around that nucleus we would have a whole bunch of electrons around here, right? We just don't have them drawn in there. Okay, so we're just looking at the nucleus, and since we're splitting that nucleus up into 2 other atoms, changing that nucleus, that is a nuclear reaction. Alright, so types of radiation. I said the rays and the particles given off by these unstable particles are called radiation. So there's three main types that we really look at. Okay, the first one are alpha particles. Those have a 2+ charge. And sometimes you'll see them written in a couple ways. You'll see maybe an alpha symbol like this, or it's actually a helium nucleus. Okay, so it's a helium stripped of its electrons. And so that is an alpha particle. Okay, the next one, skipped one, beta. Okay, a beta particle is basically an electron. Okay, a beta particle is like this free electron running around. Okay, it's a negative charge. It has no mass. So I put a 0 up here because it has no mass number. There's no mass, but it does carry a -1 charge. So that is literally an electron. But we refer to it when it's involved in nuclear reactions, we refer to that as a beta particle. Okay, and the third one is a gamma ray. So here's our ray of energy, not really a particle, but it's a ray of energy, has no charge, no mass, and it's the most dangerous of the three. Okay, so alpha radiation is radiation that's deflected towards a negatively charged plate. So if we go back here, we see a negative plate down here. Okay, the alpha particle is going to be deflected towards the negative, so it's going to be attracted to that negative plate because it's positively charged. The beta is going to be attracted to the positive plate because it's negatively charged. Okay, so attracted to the negative plate, alpha particles contain 2 protons and 2 neutrons. Okay, like I said, it's basically a helium nucleus, and here we see it in an example of a nuclear reaction. Okay, here we have radium-226, so radium-226. Right here we have radon-222, and we have our alpha particle here. Another way that we could have written that is we could have written something like that, but we use the alpha here because we're talking about nuclear reactions. Okay, so notice that we started with radium and we ended with something else. We started with the element radium, we ended with a different element, so that's a clear indication that there is a nuclear reaction going on, and in this case we're giving off an alpha particle. Okay, beta radiation is the radiation that's, like I said before, it's deflected towards the positive because beta radiation is negatively charged. Like I said before, it's just basically an electron. Okay, here we have an example of it in an equation. So during beta decay, a neutron is converted to a proton. So that's kind of interesting to think about. A neutron is converted to a proton. So that atom is gaining a proton. And remember, protons are what determines determines the identity of that atom. So if we start with potassium 19 and a neutron from potassium turns into a proton, okay, protons and neutrons contribute to the mass number. Well, we're exchanging one neutron for one proton, so the mass number actually doesn't change. But the number of protons, or the atomic number, does change. So we started with potassium, we're ending with calcium, and we're giving off a beta particle. So nuclear decay, that's beta decay because we're giving off a beta particle. Again, if we take a close look at it, we start with potassium, we end with a different element, and so we give off some sort of radiation, in this case beta radiation, and we have a nuclear reaction. Okay. Gamma rays are very high energy radiation that has no mass. Okay. Gamma rays are neutral and are not deflected by the electric fields or anything like that because they're neutral. And because gamma rays are massless, the emission of a gamma ray by themselves cannot result in the formation of a new element. So in this particular case, we're not changing from one element to another element, but gamma rays are considered radiation and part of nuclear reactions. It's just the energy form of that, of nuclear, anyway, energy that's involved in nuclear equation, or nuclear reaction. Got through that. That's crazy. All right. So back to our focus question: how can atoms change? Okay. So through nuclear decay, atoms can emit rays or particles to form in the form of energy. Okay. And then when this occurs in unstable atoms, it turns one element into another, except for the case of gamma rays. Okay. But our dead giveaway is that we do change one element into another element during a nuclear reaction, and that's just plain bananas. No, really, it is. Actually, bananas have potassium in them, and so that potassium reaction we saw earlier, see, if you have potassium 42 in your banana, which you do, means that your banana is actually radioactive. But it's okay, because you're going to have to eat a huge amount of bananas in order for them to be dangerous to you. Anyway, thanks for watching, and we'll see you around next time.